Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We just finished adding in all of our new sound effects from Kane, so we've got a bunch of different sound effects now throughout the game of like pushing and colliding. Oh, we don't have a crate destroy. We're gonna make a note of that. A break crate sound effect should probably happen there. I think we're at the point where, you know, since we're not, I think we'll add that crate break sound to the list of neededs. But I think the next big thing is the saving and loading for our global inventory system. So this one is tough because depending on when your last save is, it determines what things you have unlocked in your item inventory as well as your key item inventory, and also what you have currently equipped either in your spell slot, your A button slot, or your item slot, your B button slot. So when we go to save it, you know, we need to take all these things into consideration. We need to save what's currently equipped. We need to save what's currently unlocked. We need to save where in the inventory are the things currently at so that we can load them back in later in the same spot. Because if you unequip something with the select button, it kind of places it back in your inventory. So you can equip something, and if you don't want it equipped, you can unequip it. So the loot can either be here in this first grid 1-1 spot, or if we equip that, now the loot's there, and we can unequip the potion to be in the grid 1-1 spot. So and we don't have a lot of ways of tracking this. I guess other than we should maybe make like a status on our inventory system, and the status has all the things that are unlocked, you know, like the green tunic unlocked because you have to pick up that item, or the spellcast element Flama because that can also be equipped and saved. Yo, Soup, thank you for the sub, dude. 16 months is insane. Thanks, man. Yeah, 16 month streak is pretty nuts, dude. But yeah, we're trying to conceptualize how the save data should work for the inventory system, and especially since a lot of the current inventory system gets like initialized, it overwrites whatever may be loaded, unless we defer the load a certain amount of time, or I don't exactly know. So we're gonna maybe make like a little, because like one hard thing with this is that we're taking this data from Lua as a table, and then we're serializing it down into binary data, and then we load the binary data and then kind of deserialize it back into Lua. And sounds good, Soup. Yeah, good luck on that, man. So I guess I'm trying to say, like, by the time we're serializing data, it's one thing, you know, like there's one step that can go wrong is we encode it incorrectly and save it to the binary incorrectly, but then we can load it either correctly or incorrectly, and then we can either, once we start the game and kind of reinitialize everything, that's another point of failure. So there's like 4 points of failure for the system that we have to kind of like hopefully take piece by piece and test piece by piece so that we know what we're getting into when we try to both serialize and deserialize the data to overwrite it so that it can be a seamless save and load experience. So I guess the move is to maybe walk through what I used to have, or talk through some of the problems, because the Bitzer library we're using for the serialization is not able to copy class objects. It's only able to copy tables. So unless I'm missing some way to kind of do it. Ideally we just say, take a snapshot of our inventory system, load the game, load our inventory system, and plop it back in there as if nothing ever changed. But I have not figured out in Bitzer how to serialize a class object, a class thing. So it's like, even though it's all tables, there's some magic under the hood that are, because object-oriented programming isn't inherently part of Lua, so we're kind of like doing it in a way. So it's kind of, I don't know. I'm figuring it out. I don't know. I don't know how it works. We'll just take it one step at a time and try to figure it out. So we do have these things called a save data utility or save player data function in our save data class. And then I know that's just how it is. It's like we all just, if it, I don't know. It's, I wouldn't say I feel like imposter syndrome or anything, but I can kind of, it's kind of like how when I grew up from a kid, as a kid, I used to think adults had everything figured out. And I'm like, bro, adults are just kids who are just in a bigger body. So I'm like, no one knows what's going on. It's all kind of fake it till you make it. But if like the act of faking it is actually making it. So whatever, we're here. Okay, so we do try to save the inventory. So since we can't copy over a class object in Bitzer, we have to kind of break things down. So it's almost like we just need to loop through all the objects in both the key item inventory and the item inventory, and then I kind of broke it down into different keys for different grids. Since the demo only has 2 items, I didn't loop through every item in the grid, but maybe we should. Yeah. I agree, Soup. I think that is right. Because it's kind of like cooking, where it's like if you fail to cook a meatloaf, but at the end you have like a meatloaf looking thing, you really cooked it. It's not perfect, but you did it. That's kind of how I feel about it. Okay. And it's tough because we can't really print anything to the console debug because it drives me crazy, and with Tmux or with WSL it just screws up, and then I don't like using Zero Brain Studio for the debug option there either, just because it's so hard to run and it's not very intuitive, and it's, I don't know, it's just weird. So maybe we try to figure out Mob Debugger again, because at one point we tried doing that, but I feel like Mob Debugger was only helpful with Zero Brain Studio. So ideally what we can do is kind of save a snapshot of our global inventory system and then analyze it, or at least make sure we're not missing any for sure data, like it's an item type, it's an item quantity, and it's active spot or not. Like the object gets stored into the grid location, so there's a different grid for the item inventory and the key item inventory, which all needs to be saved and then overwritten without that overwrite being overwritten in the init when we do this stuff in the play state or whatever. So we might have to like defer our loading a bit until everything gets initialized. Then we load and overwrite it with the updated values. Maybe that's the way to do it. But yeah, it'd be nice if we had a better debug. Maybe the debug console is just mainly screwed up when we're in full screen mode. I feel like it's just so bad to use. So let's try to save some save data and analyze it with the console, our Lua conf console debug printing. So what we're going to do is say only if there's an item equipped in our item slot by the time we save the game, we're going to save both the type and the quantity of that item slot. So the things that are in an item slot is an equipable item, be it a loot or a health potion at the moment. Those are the only two that we have. So if there's nothing equipped, then we save in the save data an item slot type of nil and an item slot quantity of nil. Now we're storing those values into the key of a save data table. So this is how we eventually serialize into one table and then deconstruct and reconstruct upon load. So we're taking the item slot, we're saving it, and then what we're doing is we're going into the grid 111, which is the grid is in our item inventory. So this is telling me we're going into grid is the first row, first column in the item inventory, and then the third one here of this array is an actual item that is equipped. So we should also check if there's an item that's equipped, we're going to save it, and not equipped but just in the slot, because there can either be an item in the slot or it could be empty because we have equipped the item that used to be in that slot. So in order, this could come out nil, and then screw up some loading or something. So I kind of want to just do a little check here. If the grid at 1 does not equal nil. So as long as there is an item in that grid, then we're going to save that data for it. But we might want to put, I think we want to put this in the else of over here. I think we want to say, I think we want to put this here. We end this. We put an else. Because we're basically saying, if there's nothing equipped by the time we go to save it, if there's nothing equipped in that first slot, then we're gonna the stuff we're gonna save is an item that our inventory grid 1 type gets nil and grid 1 quantity is nil. See how this method isn't so good because we're having to name the keys that we're saving as very specific keys. Ideally, we can kind of just push it into a table, I guess, and if we know which order we push it in, we can pull it out one at a time and not have to worry about very specific key names. But also in the debugging process, it's probably easier to just have the names be verbose like this. So, and then we actually check here. I don't think it's this third array here, because then we're asking the second item, which would be our health potion or whatever. We're saying, well, if that second spot does not equal nil, meaning there is active value in there. If the table's just initialized, it would still be nil. But if there's actually an object stored in that 2D array, then we want to save and see how we're saving the grid 1-2 type, grid 1-2 quantity. And we're putting that from the object that would be in there. That's the one of our 1-2. So our first row, second column item that's in the grid, we're taking both its type and quantity out and saving it into the save data table. If there isn't a thing, well, then we just initialize both of those values to be nil so that we can save and load whatever the values may be. I guess if we try to load, we would just say, well, if it's not nil, let's do it. If not, whatever it got initialized as, let's just save it. So this is where we are adding this save data save utility method basically. So let's just put here, this is just like save item inventory, but we have to do it for the key item inventory too. So we're just going to check it one part at a time and try to figure out what we need. So let's put our console printing back on, which I absolutely hate in WSL, but the next thing we want to do is go into our play state. I would say maybe actually in main state, because regardless of the state we're in, we want to be able to see the values that we are deserializing out of our save data. So I guess we can just say here, and we would print to console, I guess, the we can say item data, right? And we're going to concatenate to a string with the we want to pull out. See, this is really tough because it's almost like we want to put this on a key press or something, so that, well, shoot, because at some point we turn the binary into a load. I guess I'm trying to find where we do the deserialization. So where do we do the load player data method? We do it upon an L press and once we start the game. So this is a little, we do it if it's in a play state. Oh, actually, this is in a game over. Okay, so right now we're only doing it upon like an L button press. In reality, this would happen from a title screen state going into a play state, right? When you hit continue, it would load your game. So maybe we see if we have it there in the title screen state into the play state. Title screen state. Do we ever change into play state? See, look, we say load save file. Yes, we do a load save player data here. So let's go into our main, and we will default our state to go into the title state instead of the play state here. So we can save this game start for grep. So if we go to game start, we can find this toggle tree basically. So like if I'm over here and I want to go to the game start, this is why like people say like maybe don't use comments because it doesn't describe what the code actually does. It's just a little distracting and whatever. But using our code base, when we can grep search the game start and just jump to it, that's what I think is really useful with comments, at least with NeoVim and everything like that. So we've got the title state. So as soon as we hit continue, it would load the save data. So we probably also want a button to just like nuke our save file so that we can test things over and over. I don't know. We should have write permission to the directory that Lua defaults saving the game to. And I'm trying to think of how we even chose to do the save player data and where the game chooses to actually save. I guess it would be right here, saves. Okay, so there's what we're doing here is saying, well, we actually yeah, we do this upon a load. We create a folder if it doesn't exist, right? We say create directory save. I guess we're kind of just doing this regardless. We're creating this folder called saves in the default Love2d save location. And then if it, what do we say? Save data exists. We're going to try to run this get info on a save player data.bin. So I guess I don't know if this would delete something before it creates it or writes it. I don't know. But basically, save data exists is this get info. So if there is a thing, then there's no save data exist. We're printing this. We should be able to see this. Then it is saying, okay, we need to do this and change to opening cinematic, blah, blah, blah. Go to early break, which is just a jump statement to just end instead of doing anything else. So what else we have is, because yeah, there's nothing to load because we don't have a file that we have saved. So it's just going to early break, which ceases loading player data and just changes the state to what you need. Okay, so we are printing the save data exists table right here. So this isn't a load player data method call. And I kind of want to say, and this is, you know, if the data does not exist, it'll start a new game. If the data does exist, we are inspecting. See, I don't want to inspect the save data exists. I want to inspect the save data that we actually load from this function. So I don't care for this. I don't need this at the moment. So let's continue, because we create a load variable that we get from our bitzer load love file, and we're actually loading the save player data binary that we just serialized. So then we have, I don't want that. Then what we do is we cycle through the load, because this load love file, this bitzer will like deserialize it and pull each thing. So this is, I'm sure there's a better way to do this, but we're basically just asking if the key is equal to whatever data we're looking for, then we overwrite the new player's values with the value that we are loading from the save file. So right here, we're saying, okay, well now if our item slot type exists and is not nil, then we're going to overwrite the item slot with an item instantiation of the value that we stored in there, which in an item class, the option is what gets passed as the parameter, and the option determines the type here. And then I believe the type just tells us what to render. If it's a type loot, render the loot icon. If it's a type health potion, render the health potion. And then the quantity also needs to be copied over too. We left a little note here saying that we were kind of doing this, but we also are saying we need to equip the item that is in the item slot 1 to actually make our player wear it. That's what equipping will do, is it says the loot is in the A button slot, but the equip will actually make the loot appear on our person. And then we're setting the quantity equal to, now we could say, see, this is kind of, yeah, this is weird, because we're not asking if any of the keys in the loaded data ever equals item slot quantity, but we can infer if we have an item slot type actually saved, then there was an item to load. Therefore, the quantity of that now equipped item is just going to be equal to load at the index of item slot quantity, instead of asking if the key in the load table was slot quantity. So we're kind of just assuming, okay, well, since we made an item slot type, we know there's an item slot quantity that needs to be assigned into the now active global item inventory item slot dot quantity. Jeez, man. Okay. Then we're doing this with grid 1.1 and 1.2. And we're saying, well, if there is a key called grid inventory grid 1.1 type, then we know that we need to add into our grid 1.1 an item instantiation of the value, which is the string of the name. I mean, because it's the type that we pass in. Then we also do the same little trick where we assign the quantity of that third dimensional array here, 111 dot quantity, to load the quantity value that's in the key stored at the load table. And same thing with grid 1.2. And then what we do is say we print loaded and then loaded whatever key concatenated with whatever value. So I kind of don't really care about whatever key it sounds it makes. And the value is going to be whatever we saved, whether it be a string or an integer. So maybe we can say, yeah, I don't know. Loaded K as to string B, and then print game loaded. Okay, so let's we basically need to, I think we need to delete our save file, create a fresh save file, and then we can test the Bitzer or the Love console printing to screen debugging. So let's go, and our saves aren't in the repo anymore. They're actually in where Love saves it. We had it where we would save here, but if we want, I think there's only read and write access that Love gives you from the save directory for reasons, security reasons, I guess. So this is where our data bin is. We're gonna delete our save player data so that we can resave a new one, and we'll see if we had printed up the value of the save when we did this. What the heck, man? Okay, so let's save and see. So it should actually run the opening cinematic because we don't have save data. So it's playing the wrong music. It's gonna mess up a couple of the things. We have a green tunic equipped when we shouldn't. So like there's still unfortunately so much stuff to do, but we can mute that. Yeah, it's like yeah, this is really tough. We should maybe make a backup of like a basic save player data just straight outside the Mage's Castle here, so that we can restore without having to play the whole cinematic here. Okay, so we're gonna save the game by meditating. Okay, here we go. We meditate. Game successfully found. Game save successfully. Starting new game. I don't know what the ound is. Okay. Oh god. See, it doesn't matter if it's full screen or not. The console debug is just jacked up. Okay, so we have a save data. I do want to back this save data up so we can restore it without having to play through the whole intro part again. So we're just going to duplicate this and save it as a dot back. Okay. So let's try to load the game now and see what we print to the console here. Okay. So it says game loaded. Health potion unlocked was not unlocked. It saved our health. It saved that we had a loot and a health potion equipped in our item slot. So health potion unlocked was either true or false there. So at least we're pulling loot and health potions. So as long as that was what was in our grid, then we maybe have done the first part of that encoding part correctly. So let's see, because we don't have a loot here. It's just not rendering. So we might not be loading it. Oh gosh, dude. See, this is what's so fucking rough. Okay, yeah, we wanna double check something in our save. So this is jacked up. Either in the save or the load, we're trying to figure it out. So this is part of the reason why it's just so tough to do this. So we're going to restore our binary data here. And we're going to just load the game again. And this should be the recently saved version, right? Right out from the get-go. So we go to load. It has all the same stuff. It actually, yeah, it has our loot and health potion here. Now this is... You know what? I think this is before. This isn't saving. Huh. So this save didn't have the incorrect stuff. Okay, so I think instead of actually loading the game, I think what I want to do is just print the status of the debugged save file. Not debugged, but print debug. Because I don't want it modifying the tables and screwing the game up. I just want to see that the information was encoded properly. So the fact that this hasn't given me the correct data tells me that we either didn't save it or load it correctly. So I just want to change our load. I don't want it to load. I don't want to call our load player data just yet. So I just want to mess with the binary save data. So I guess what we do, I guess that means we go to every player load, and it's called save data. No, what is it called? Load player data. So we load the player data from the title screen. We are just going to turn this off for now. We don't want to load. We just want to print the player data, which actually we might have to turn this off in the method just to make it easy. Okay, so what we're going to do, we're just going to comment out the part where it actually overrides values, but we're going to keep the part where it prints the debug to console there. So we're just going to turn off the loading part of load and instead just say, here's what was pulled, here's what was deserialized from our save data so that we can just check. So now what we want to do is save with a couple of things in mind. We need to define our early break, so where did early break go, dude? Oh, down here. So it's this that needs to be turned off. Okay. It shouldn't have loaded there. Why did it load? Did it load upon pressing start? Okay, so we can't pull... Oh my gosh, dude. Yeah, we do need to create this table, but when we cycle through it, this is when we're going to turn this stuff off. Okay. And then I think we need this. And okay. So we took out all the load aspects. This shouldn't crash here. Let's see. Okay. So what we're going to do is we're going to save with a loot and potion in our item slot. So now what we're going to do is load our game by hitting a continue. Okay, so this just loaded. Let's check it out. It is saying, hey, we had a type of loot in grid 1-1. We had a inventory 1-2 as a health potion, and we had a quantity for that health potion. So this means we saved it appropriately. We can test this. Yeah, we can test this by maybe spending some of our potions, saving the data, reloading, and seeing that value. So let's say we had a potion and we used it down to 9. Then we come and save it. Oh, no, man. Save data 40. Don't like it. It just didn't like this. Save data 50, not 40. It saved on the, or it crashed on the save, right? Yeah, so it's saying, we're saying if I don't know. Let's try saving it again. Okay, game saved, but then if I come here, save data 40, it is 40. Why did... So when we use the potion, we equip it into our item slot. That leaves grid 1-2 nil in this scenario. So it's basically saying, well, when we go to save the data, when we have 9 potion, the grid is nil at 1-2. At least it should be, because we removed. Yeah, we equipped a health potion, leaving nothing equipped in 1-2. So since it is nil, or should be nil, maybe we can just confirm that on the save data. I mean, we're crashing here. But we're only crashing here when we save with a health potion equipped. So maybe we can just say, like, right here, this is grid 1-2 was not empty. Because if it was empty, it would hit this condition instead of the else. So do we say, do we want, yeah, like grid 1-2 is empty. Because what we're trying to do, it crashed on line 40, which was right here, when we saved it. So that's telling me that we hit this condition, which was grid 1-2 did not equal nil. So we might want to print up what this grid 1-2 is and make sure that it changes once we unequip the health potion, because it might not be nil. I don't know. I have no idea. I have no idea. Grid 1-2. So let's just say in the play state, we're going to print up what's at that grid 1-2. So we're just going to say grid 1-2, and we're going to inspect the global item inventory for the grid at index 1-2. And we're just going to inspect that whole thing. So there should be nothing in here by the time we equip a health potion, but I'm assuming that something is going on with that because of the save issues we've been having. So let's see. Okay, so it says grid Grid 1, 2 is not equipped. It is a type of health potion, yes. If we equip this, this should be nil now. And it's not nil, it's just a empty table, so it's not nil. Does Lua have asserts? I don't know. The assert keyword. Let's see. It looks like it does. Assert value, comma, message of error. Okay. Let's see. It looks like you initialize a value, you use the assert syntax with a lowercase or uppercase, I guess. I mean, it could be a cool thing to know. Like, you know, I might find a use for it if I know how to use it. We just assert that, dude. And then all the typos. Like, if a tutorial has typos in it, I'm like, dude, you clearly don't care about this. Assert. Okay, invalid input is not a number. Yeah, they really are. I mean, and especially with like AI autocomplete, sometimes it's just so not right. Okay, so I guess asking it if it is nil is not the right move here, because we initialized it as an empty table, so that's not nil. It's just empty. Yeah, that's for sure. Okay, so I guess what we can maybe try to do here is I just want to test something and say, I think I just want to test if we can convert to a string the result of a boolean of asking if this grid is equal to an empty table. Can we do that? Can we cast a condition? I don't know if that works like that at all. I guess it would just be, you don't ask it, you just evaluate it. Yeah. Yeah, and then we just do a double equals empty table, concatenate or cast that to a string, and then print that. I don't know. False. But if we then equip it, does it? True. Let's see. False. Okay, now it's empty there, and it still says false. So, is that working? Dude, this is driving me nuts. Because it's saying false, so that's telling me that the grid at 1, 2 in the item is not equal to an empty table. But we inspected it, and it was an empty table, right? Because we are right above it at G12, we're actually printing the thing we say it is. And that's a big old table of things. Once we unequip it, it's an empty table, but it's still false. Okay, so we don't have an ability to do a conditional like this. Let me try something. let's try this like this and say if the grid is equal to an let's try this, an empty table, then we're gonna print out, we're just gonna say nothing is in grid 1 or whatever. We're just gonna say 1, 2 is empty. Okay. This would be 1, we can say 1, 2 is, and then put whatever was in the grid 1, 2 type, cast it to string. Okay, let's see. Well, okay. 1, 2 is nil. So that, okay. 1, 2 is nil instead of, so the type is nil. And the type, you know what, the type is actually, we'd have to do this, that third. Hey, Doomwretch, what's up? Okay, we cannot index a nil value right here. Okay, so it's hard for me to say because it gets, we know it's empty, but what I'm trying to figure out is if we can do a conditional when it's equal to an empty table, because when we just print it up, it says it's an empty table. But then if we say, is it equal to an empty table, which is what it's printing out to be, then let's say the table's empty. So let's try calling this nil instead of empty and see if it's treating an empty table as nil. 741 crash right here. Let's just turn this off. I think that, I mean, that must mean the nil check failed here. Yeah, I mean, it didn't print anything. So like the empty table we see there is that grid 1, 2, and that's what's stored in grid 1, 2, which is nothing. But we're trying to find out what condition we can ask in order to do something if that was empty, and a conditional checking nil or an empty table isn't working because we don't want to save the data if it's empty, and we want to load the data very specifically if it's not empty, and that's just a little tricky with us not knowing how to evaluate the actual condition of that grid 1, 2. So we're printing up that it's an empty table because it is, or it should be, because that's telling me that there used to be an object in that grid 1, 2, but we took out the object but left the structure of like the table that's left over, because it's an empty table. It's not nil. It's an empty table. So, but then, you know, how can we say if it's equal to an empty string, then it's empty? Because equaling an empty table, it doesn't say that. So that doesn't work either. And we can't test for equality for an empty table like this either. Okay, so what do we do? We could do the number operator and check if it's equal to 0, I guess. Yeah, Lua's got some quirks, man. But I guess what we can do is do the number operator, and we can say if the number of things that are in this table is equal to 0, then we know it's empty. Otherwise, print up the type of the thing that's in there. So let's see if we get the empty print string here. Okay, 1, 2 is empty. So this is a way we can do it. So we use the number operator there. Okay, so now that we know this is the condition we need to check upon the load as opposed to what we did have. And that might fix certain things. So let's say load player data. And when we go to check, let's see, right here. Well, I guess, you know what, this isn't where it's messing up either. But at least we can. I think it's maybe in the save, because we want to save it not if it's nil, but if there's nothing in the table. So I think that's where we're messing up. So right here, yes, instead of saying if it is not equal to nil, we say if the item that's in grid 1-1, which right now is a loot, we say if number operator, that table, if that is equal to or I would say greater than 0, if there is an item in there. Yeah, if there is an item in there, and you know what, instead we can say equals. No, I think that's right. It's yeah, if there, gosh, does that make any sense at all? Basically, if there's an object in our item grid at 1-1, then we're gonna say, yeah, I don't think we need that, because that's what we're asking here. Okay, so then we're gonna save the grid 1-1 type and 1-1 quantity into the save data table here. And this would be nil. So as long as it's not nil, then there's a valid save data in there. So instead of doing this one too, say we're not checking if the thing in there is not nil, because it's actually not nil, it's an empty table. So that won't happen. So let's do the number operator and say if it is greater than 0, then there's an item in there. Therefore, we want to save the data for the 1-2 type and quantity from the item that's actually in that 1-2 array. That's why we have the triple 1-2-1 array, 3-dimensional array. And then here we're saying grid 1, 2 was not empty, just to help us. Because this is in the save. I guess we can add little prints along the way saying grid 1, 2. Well, let's see. Grid 1, 2. Yeah, we have this wrong. I'm using NeoVim, so I can delete and paste and stuff really easily. So I'm using all the keyboard movements instead of the mouse, if that's what you're asking. Yeah, I think it's grid 1, 2 was not empty. Therefore, we save grid 1, 2 type and quantity. Otherwise, this would mean grid 1, 2 was empty. So we're just trying to check. Yeah, we're trying to check certain things, and this is upon the save data. So let's try to save. Okay, grid 1, 2 was not empty. It was not empty. So let's make it empty and save. Grid 1, 2 was not empty, even though grid 1, 2 was empty. Shit. Oh, we're printing the same thing. So was empty. Should be here. Yeah, let's try this. So let's try to save. Okay, we're making grid 1, 2 empty. It says it's empty. We're going to save it while it's empty. And it says grid 1, 1 was empty. Yeah, grid 1, 2 was empty. Okay, so it knows grid 1, 2 was empty. So therefore, we're putting nil in the type and quantity. This gets a little more complicated because what's going to happen is our game's going to look through our global, or it's going to initialize our item inventory, and it's going to input. I don't know if it does it. Let's look at the init for the global item inventory. It does have Game Boy controls. Yep. So if you go to Tashio.dev on your smartphone, you can touch the Game Boy D-pad and the buttons and try it there on your phone. That's the best way to play it like a Game Boy, in my opinion. So it's like, because there's going to be a mode in the full game where you can put it on Game Boy View and it shows the buttons that you're pressing, but we don't have that optimized for the stream just yet. So it is gonna be in the game, but it's not there now. Okay, we're looking for the item inventory. So when we do, or it's just an inventory object. Okay, so here's what we do. We make a grid, right? We have an option. We set a grid for both a key item option. Okay. So we have the table. Then we go and we cycle through the grid for the amount of rows and columns, and we initialize with an empty table. And then we kind of insert an actual item instantiation, just like this. Table insert into grid 1, 2, an item object with a type and a quantity if needed. Okay. Okay. So the tricky part here comes from now that we have the data serialized and deserialized. When we load the game, we need to initialize our global item inventory just as it normally does, but once it's initialized, then we need to actually load the data. because right now we're loading the data as soon as we hit enter on the title screen, and I guess we can check the order of operations when we hit that. I guess it would be, yeah, change to play state. Right, so in our title screen state, we're changing the state to play state, which should be initializing all these little variables. But actually, yeah, you know what? The way Lua works here is it says change state machine, but it doesn't then dive into this state machine and execute all of this state machine's code. What actually happens is it says it'll change to the play state, and then it continues to scroll and execute all of these lines, and then it'll load the play state. So even though load player data is after play state, and we initialize things like the item inventory in the play state, this load player data isn't overriding those values because we're not actually updating the play state until we execute all the lines in the current play state. This is why we had to use the jump conditions for the load, so that we can control this and behavior, which is like not intuitive, and I had to figure that out. So I'm pretty sure that's how it works based on past testing. So it's just one of those things. It's like we're using a library for a state machine that we didn't write. So like I was just kind of assuming it worked in certain ways, and I've been finding out that it's not as I originally expected, which makes total sense because there's a lot of moving parts. So we have to find some way to basically, it's like an asynchronous kind of function we need to do here, where because we need to make sure we initialize all the play state variables, then we load the player data to override it. So I don't know what that means. I guess we could. I don't know what that means. Because yeah, ideally it's a kind of like asynchronous thing, but we can't show anything until it's loaded. I mean, it's like I'm coming up on a epiphany of having a loading screen in a video game. Like, because yeah, we just need to initialize all the stuff without actually letting the player play and everything, right? So it's like a freaking loading screen in between the play state and the press load. Yeah, we might end up, even if it's like one frame of loading screen state where it just renders black, we could change the state to a load state here, and then put the load player data in the load state init. So once it actually initializes, but it initializes in the play state. So we'd have to. Yeah, and it's not that it just... Yeah, because the... basically every time we have classes and stuff, we initialize it as one value, but the save data needs to overwrite those values. Currently, it doesn't overwrite it because they're initialized. Well, Yeah, you know what? I guess I don't really know why. Well, and that's another thing with a state machine. I'm pretty sure when you change the state machine, it reinitializes everything. It runs the init again. I guess I don't know that for sure. Let's test that, I guess, and say maybe what we can do is put a little counter in the play state, initialize it to 0, and then increments it in the update. And then if it goes back to 0 upon going back to the play state, then we would be running the init whenever we run change. Because that would be useful information to know. I think that's what's happening, but I don't exactly know. So let's do that. Let's go to our play state. Yeah, let's go to our play state. And we're going to initialize a test counter. And we're just going to say test counter is initialized to 0. And then every second in the update for the play state, we're going to increment. So we're going to set test counter equal to itself plus 1. So if... Yeah, so let's just see what happens, because I think... Oh, we're not printing it up. That would be nice. So we'll also print up the test counter here in the play state and put it just right here. So, test counter. Okay, I'm gonna take this out. Let's see. So it should count up, and then if we switch to a pause state and back, dude, it does. It does. Because we're never flushing that value other than we initialize it to 0. So that means when we run the change method on our state machine, it reruns all the init. So anything that was of correct value in the save file, if it has any sharing data with the initialization, it's going to get re-initialized. Now re-init. Yeah. Okay, so that is what I thought would happen, and that's why I did it the way I did with or that's like the reasoning we came to conclude, right? Where when we're loading this from the title screen state, we change to the play state, which in my mind, you know, changing to the play state might mean both we don't reinitialize the play state, but then we just resume to update the play state, but it does mean reinit. And this load player data happens before this actually gets initialized, which is another kind of whammy that is like, you know, non-congruent with how I used to think how Lua and Love2d works, at least with this state machine. So yeah, we just need some sort of async for the load so that we can, when we change this and after it actually changes and updates and reinitializes, then we load the data. So we can, maybe we just add into the play state, we just say, hey, if there is a save data, we do the load here in the play state initialization. After everything gets in it, then we load and overwrite. So that might be the move. I'm not going to do that right now because if I get close, I'm going to just be, you know, probably frustrated. So we're just going to call it there, and we're going to try that tomorrow. Which would be really nice if we can get the, like, this is what I had, like 3 bad days of failing on this, and then I took like 4 days off streaming after that just because I was like disheartened. So like it really sucked. So I don't want to get to that point again. So let's say that we are slowly adding print debug. Hey, thanks for the follow, Doomrich. Slowly adding print debug for inventory save system. Cool. All right. We're going to run credits. Oops. And find someone to raid. So let's run credits. Okay. Let's see. Sninko's up. We might hit up Sninko. I don't know if I know Sophie Dev. Let's see.
Windows XP. Y ya está.
Oh, to get in. Different language. Let's see. You know what? We'll just hit up Sninko. We rated him yesterday, but oh, he's not even. Hold on, he's not even streaming yet. Shoot. Yo, Matt Bird, did you just join? We are raiding out here. What, dude? Did you play Mina the Hollower, Matt Bird? The demo is amazing, dude. Thank you for telling me about that. Wow, I really don't see anyone. We'll raid Triple Jump again. Looks like he just started a stream, so we can just raid out. Thanks for hanging, y'all. I'll be back. Tomorrow we'll get some more saving and loading done.